Hey everybody, I know you got your quiz tomorrow, so I was going to run through this review guide again for anybody that wants to hear it. So let's start with number one. In number one, we're talking about just a translation. So again, I could do a handful of things to help you kind of visualize this. First thing I can do for sure is just literally highlight the triangle for you, and we can watch it move. So when you're translating, you should see the triangle. Oh, rats. Those things are supposed to be connected. Give me 1 second. All right. And yes, it is cool to say rats. You guys should say rats. All right, look. When we're translating, this figure should just slide. Okay? It can slide straight down only if it wants. It can slide straight to the left, or it can go down and also left, which really is just a diagonal translation. So, you know, if you had all this, an easy way to do this problem would be to just make the triangle and do these transformations. What's it say? Translate 4 units and down left and then down 5. So you know what's going to happen is, I'm kind of following point A right now. But when I grab point A, I would just go 1, 2, 3, 4 to the left, and I'd go 1, 2, 3, 4, 5 units down. And now that's it. Like, that's my figure, right? And we could use the patty paper to do this. If you want to move the whole triangle all at once, the patty paper would help you do that. But I can just look at this now and see that the new A prime right here is at -1, -1, 2, 3, 4, 5. So that's it. I can write down that. A lot of people have been forgetting to put parentheses around their coordinates. So make sure you don't do that. That's bad. So -1, -5 is the answer. And that's it for A prime. We can see the B is right here. It's at +1, -2. And C prime would have gone here. It's at -4, +1. And then what's the rule for this transformation? The rule is that xy maps onto, well, let's see, x is still going to be x, y is still going to be y. But if I'm going left 4, then all my x values are decreasing by 4. So all you do is you subtract 4 from the x value. And if you're going down by 5, then all your y values are decreasing by 5. So you're going to subtract 5. That's going to reduce them, make them smaller. That's going to make you go down. But that's it. That's how you do this. You know, again, I know you guys don't have all this fancy stuff that we can let you draw triangles and drag them. So if I were you, I would just do it with all the points, 1 point at a time. You'd start on point A, and you just imagine moving 1, 2, 3, 4 to the left, and 1, 2, 3, 4, 5 down. And do the same with B. Starting on B, you go 1, 2, 3, 4, 1, 2, 3, 4, 5. And there's B. Do it again from C. 1, 2, 3, 4, 1, 2, 3, 4, 5. And then there's your triangle. And then you can roughly connect the dots. Doesn't have to be perfect, although my lines are looking pretty good. That's it. Before I didn't label my vertices, but that's important too, so make sure you do. Mark this point as A prime, this one is B prime, this one is C prime. It does say you have to do that. It says label the image triangle as A prime, B prime, C prime. So you have to label it using those primes, okay? But that's it, or is it? There's really one other way. One other way to do this would be just find the coordinates of all the given points. Point A is at 3, 0. So if you know this rule already, you could use it, because we know that point A is at 3, 0. So where's that point going to land after we transform it? Well, we subtract 4. That's going to give you -1. Then we subtract 5. 0 minus 5 is -5. So you can find these coordinates by finding the original coordinates and then applying this rule. And then you just plot that point. -1, -5 means starting from the origin, I go left 1, down 5. And that's a third way to find A prime. And you could do that with all of these, because point B is where? 3, it's at 5, 3. So applying our transformation, we subtract 4, we get +1 in the x position. We subtract 5 and we get -2 in the y position. And so again, we're finding all those points, lots of different ways. All you got to do is give me the right drawing. You got to give me the right coordinates. You got to give me the right coordinate rule. Okay, let's move on. So this time you're being asked to rotate 270 degrees clockwise, but as I said in class, I don't want to do that. I don't ever want to rotate 270 when I could just rotate 90 instead. But I can't keep going clockwise. If you want to change 270 to 90, you have to go the other way. So make sure you change the clockwise part to counterclockwise. So that means we're now going against the clock. Clock wants to go this way, so we're going to rotate this way. So you can see that the bulk of the figure is going to move from quadrant 4 up to quadrant 1. And that's worth thinking about because you know in quadrant 1 all the x's are positive, all the y's are positive as well. So that's kind of a quick, easy trick. So how do I rotate this thing? Well, you could use patty paper, that's for sure. I don't know what my preference is, honestly. I guess my preference would probably be for you guys to know the coordinate rule. Because for a 90-degree rotation, we said the coordinates are always going to flip. It's going to go yx. Then we said we're going to have to change the sign of one of these, and it's always a little weird to try to remember. But the advice I gave you was imagine a line pointing north, and imagine rotating in the direction that you're given, so counterclockwise. That has us rotating that away. So it's literally pointing to which coordinate needs to have its sign changed. It's this one, the one in that position. So once you've got that rule, I think I might go that route. So point A is at 1, 2, 3, 4, 5, -4. So if the original point A is at +5, -4, then our new point is going to take this y value, move it into the x position, and change its sign. So it used to be -4, it's now +4, and it's in the x place. The 5 is going to change over into the y place, but we're not going to change its sign. We leave it alone. So +4, 5 would be the image of point A. So +4, 1, 2, 3, 4, 5. That spot right there must be A prime. And then actually, point C and point B, well, point C is easier. B is not so much easier. So B is at 3, 7. So when you perform your transformation, again, 7 is your y value. So it's going to now come first and be changed to a negative value. My bad. I have made a mistake. That's why I'm glad I did this. Remember when I said we're going to be in quadrant 1, so everything's going to be positive? So I knew that couldn't actually be -7. The mistake I made was in the beginning, over here when I gave the coordinates. I said 3, 7. But we've gone right 3 and down 7. So the original coordinates needed to be 3, -7. That's my bad. So now when you go to switch it, it started out negative. So we'll switch it to the x position and we'll make it positive. And then the 3 switches and we leave it alone. So we want to plot the point 7, 3. That means going, what, all the way to the end and then up 3? So we'll be there. That'll be B prime. And then we can do C. Now C is just at 0, -1. So that means we'll switch -1 into its new position and we'll change its sign, so it's positive. And 0 will switch. And there's our new coordinates. So C prime is just at 0, 1. It's right here. C prime. Then we can connect the dots. And hopefully that looks right to you guys. Again, if you needed proof, I could prove it. I can prove it by drawing a little copy of this triangle. And they're not going to be stuck together, so let me stick them together. And then I've got this little rotation tool. So if I place this on the center of rotation here, I can actually show you guys that if we take this thing and rotate it 90 degrees, it's really hard to do this slowly, but it's going to go this way, around and around and around and around and around. Ooh, that doesn't look good. Why does that look so bad? Because I misplotted point C. Ugh, I think I might be too tired to do this. I'm going to keep going anyway and push through. but I got C wrong again. I'm sorry. I'm going to get better on the next one. So C was 1, 0. C should have been here. That's C prime, which means our triangle is actually a little bit differently shaped from how it was. That looks better. It did actually look weird to me, but I was trusting myself. Shouldn't have done that. All right, I'm going to redraw the thing and double check it because now I'm just not even sure. So we'll go here to here, here to here, here to here. Then I can grab this triangle and this time rotate it for real. Now, when you see it rotate, it's going to come around, 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 around. And there you have it. Now you see it picking up point A and B and C. So we're in the right place. We did it right. Gosh, let's move on before I screw that up more. All right, this next one is another rotation. So I'll probably keep my little center handy. This time we're going 90 degrees clockwise. So if I go 90 degrees clockwise, if you plan this out, you're starting in quadrant 1. This is your pre-image in quadrant 1. So a 90-degree clockwise rotation, you can see it's going to land you in quadrant 4. And again, I think it's worth your time to think this through. We're going to have x's that are positive and y's that are negative. So what are they going to be? Well, with A at 3, 0, I want to think it's kind of easy to see that the way A has moved once we rotate is that A is just kind of sitting on the end of this little bar. And if we let that bar rotate 90 degrees, you see it's going to rotate from the x-axis just down onto the y-axis. And that point right there is going to be A prime, right? That should be an easy rotation to visualize. I hope. Maybe it isn't, but I hope it is. But we can see that that's going to make our new coordinates 0, negative 3. And just by doing that one point alone, maybe now you can see our rule. Our rule is that the x's and y have flipped like they did before. And you can see that, oh boy, doing it again, making mistakes. It's yx, right? We have to switch the order. And then you can see that what's happened is the original x value has had its sign changed. So we'll put the negative here for this rule. And then you've got your choice. You can try to do this rotation just kind of looking at the coordinate plane, or you can do it by applying the rule. I'm inclined to say we should apply the rule. So point B, where is it? 1, 2, 3, 4, 5, 3. So when we go to transform that point, it'll certainly become 3 and then 5. And we can see that the negative sign is following our x value. So we want to turn that 5 into a negative 5. And then we'll plot that point. We're going to go 1, 2, 3, and then down 5. 1, 2, 3, 4, 5. That's going to be our B prime. And then last we have C. Now C is at 0, 6. So our rule tells us that that's going to become 6, 0. And we're changing the sign of x, but negative 0 is still just 0. So we can plot 6, 0. It's going to be right here. So that's C prime. And that means our triangle is this one. And I think looking at that, you can see that, yep, that's a 90-degree rotation around the origin. So that's that. Then for number 4, we want to do a 180-degree rotation around the origin. So again, there's sort of more than one way to think this through. I'm inclined to just say that it would be best if you just knew the formula, if you knew the coordinate rule. The coordinate rule for a 180-degree rotation is change the sign of x and then also change the sign of y. So both coordinates just get a sign change. So where's A? 1, 2, 3, 4, 5, negative 4. So that means our new coordinates are easy. You just change the two signs. We're going to be at negative 5, positive 4. So that'll be 1, 2, 3, 4, 5. 1, 2, 3, 4. And that feels right to me. That looks like about a 180-degree rotation. So we'll keep going. For point B, that is at positive 3, negative 7. So according to the rule, we just change the two signs. So we'll go to -3, +7. That'll be -3, +7 right here. That's B prime. And then we have C. C is just 0, -1. So you can see that's going to turn into 0, +1. And then that point is just right here. So now you can connect the dots. And hopefully you can look at that and see how it's a 180-degree rotation. Next. Okay, right. So this is just the vocabulary one. All three of the transformations we've been studying are translation first. You don't have to go in any order, but the thing we learned first was translations, then we moved on to reflections, and then finally rotations. And we said that all three of those terms, they're called the rigid transformations. So R-I-G-I-D, rigid. And they're called the rigid transformations because when you use them, they preserve, meaning they do not change the shape or size of the figure that you're working on. If you start with a triangle, you're going to end up with a triangle. If you start with a triangle that has a certain shape, it's going to stay that certain shape too. It's going to stay the same size, same shape. Another way to say that is your pre-image, whatever it is, when you transform it and you get your new figure, they are congruent. If you're not changing the size and shape, then these should be congruent. Now, pay no attention to the fact that this seems to have gotten bigger. That's just bad drawing. All right, so you got to know all these rules. Like, yes, literally all of them. So I was mentioning in some of my periods that flashcards actually lend themselves well to this. It's already 8:06, so it's getting late. If you don't have time to make flashcards, that's okay. But hopefully, you're watching this. That should help somewhat. But I'm going to do this differently. In class, we kind of went down this list, so I'm going to go down this list instead. If you see x, -y, you can always be drawing these out. You just pick a point. Like, pick a point that goes out like 10 and it only goes up 3 or something. Imagine if this was 10, 3. Then using this rule, wouldn't our new point just be 10, -3? And 10, -3 would be over 10 down 3. That to me is feeling a lot like a reflection over the axis, right? If you change the sign of y, you're reflecting over the axis. The tricky thing is you're not reflecting over the y-axis. You're reflecting over the x-axis. The one that doesn't get changed is the one you're reflecting over. So reflection across the x-axis is way down here at the bottom. We're going to want to put that rule. The rule that says that x, y maps onto x, -y. All right, the next one. We can see that they're adding a to the x values. That's going to push us to the right, right? Adding on to x moves you right. So we're looking for the one that's talking about a translation right by a units. There it is. So that means we'll put on this line, x, y maps onto x plus a, comma y. All right, next one is this one. I don't know. Again, I just think you want to memorize this. When you change the sign of x and you change the sign of y, that's your 180-degree rotation. Okay, what about the one where you flip the signs or flip the coordinates? That was a reflection, but it was a reflection over that funky diagonal line. And again, you can kind of visualize this. Imagine if you went way out to 10, but you only went up to 3. Then you had this little diagonal line cutting through. Well, according to our rule, it just says switch the coordinates. So over 10 up 3 would become over 3 up 10. And then maybe you can tell by looking at that those 2 points are equidistant from our little mirror line, and the line connecting them is perpendicular to our little mirror line. And we know when that happens, we're looking at a reflection. So that means that one goes on that line. So the reflection over the line y equals x, that's the rule where you interchange the two coordinates. You let y come first and x come second. Okay, so after that, we have this one. You see this time they're trying to subtract from y. Well, the y values go up and down. So if you subtract and you make my y value smaller, you're just going to drag me down. So that's the translation a units down, which is the first one. So that rule again was xy maps onto. We're going down. So leave x alone. Subtract a from y. Alright, four more. This one here, we see that the coordinates have flipped, so that's making me think 90-degree rotation. Now they changed the sign of y, so which way are we rotating? Well, again, you've got that trick. Start by pointing up and then rotate toward the negative sign. We can see that's counterclockwise. So your best answer here is which one? 90 degrees clockwise? 270. Okay, so 270 clockwise is the same as 90 degrees counterclockwise. So make sure you can find the right rule and put it on the right line. So xy maps onto negative yx. Okay, so next we see they're changing the sign of x. So again, our little point over 10 up 3. If they change the sign of x, then we're going to go left 10 and up 3. And hopefully you can see that is just a reflection over the y-axis. So to reflect over the y-axis, we'll use that rule, the rule that just changes the sign of x only. What did I just agree to? I don't know. We just want this rule, negative x comma y. That's the one. Yeah, fraction across the y-axis. Okay. So now we've got the next translation. I'm just going to do that one. It's the only thing left that has a b and an a in it. You can pretty obviously figure that out. If you want to go b units left, you'll subtract it from x. That's what they're doing. If you want to go up, you'd have to add on to y to make it even bigger, and that's what they're doing. So that's the answer to this one, is that bottom rule that says xy maps onto x minus b and a y plus a. Alright, just one more. And it says 90-degree clockwise rotation about the origin. There's only one rule left we haven't used, is this guy here. And again, if I start from due north and rotate toward the negative, that is clockwise. So a 90-degree clockwise rotation is going to have that rule right there. xy maps onto. And it maps onto y comma x. And the x is made negative. So there it is. There's all the rules you could ever need to know. Translation, all the rotations, all the reflections. So yeah, if you get this, you're good. And then we're back to more of these. On your paper, I think the numbering got weird, and so yours might be labeled 1A. It should be 7A. Anyhow, it says reflect across the y-axis. Okay, sure. Y-axis is right here. So to reflect across that, you better be thinking that point A is 3 units to the right of it. So A prime is just going to end up 3 units to the left of it. We can do the same with B. We can see it's at a distance of 5 units from the mirror line. That means its image, when we bounce it over, has to be 1, 2, 3, 4, 5 units over to here. There's your B prime. And then C. C is on the mirror line. Points that are on the mirror line don't move. They just stay right where they are. So connecting the dots, we can tell that that's a pretty good reflection. But I do need my coordinates, so I'll just rip them off the grid. We see that A is at negative 3, 0. And B is at negative 5, 3. And C is at 0, 6. Yeah. And then we need a rule for this. We just went over all the rules. You guys should know this. If you want to reflect over the y-axis, then you change the sign of x, but you leave y alone. That's your rule, negative x comma y. So 8, I think for you guys, this is the second number 2. We are just reflecting across the x-axis. So this will be similar to how we did the other one. This time though, we notice that C is below the x-axis by 1. So you'd have to bounce it up by 1. But that's it. We're still just measuring distances from lines and making sure that these points are equidistant. So B is all the way down at 7. So if I'm going to bounce it up, it's going to go all the way up to 7, up there. And then A is only 4 units below the mirror line. So to reflect it, it's going to go bzzz and up to 4 units above, right there. And then that's it. That's your whole reflection. And so you can record those ordered pairs. We see that A is at 5, 4. A prime, I should say. B is at 3, 7. And C is at 0, 1. Yeah. Okay, and then what's the rule for this transformation? Well, xy is going to map onto, I don't see any coordinates flipping. I just see y values that were negative turning positive. So x will stay in its normal position, unchanged. Y, we need to change the sign of, because, you know, looking at C, it had a negative y. Its image has a positive y. That's what we're doing. Okay. How about this one? This is the one we're reflecting over the line y equals x. And again, you've got, you know, two strong choices here. It's completely possible to visualize this reflection actually fairly easily. If you remember that when we reflect, we have to move along a line that's perpendicular to the mirror line. So this is the line that's perpendicular to the mirror line and passes through A. Then what you can do is count these little diagonal units. This is exactly 1 diagonal unit. So we would do exactly 1 unit to the other side. And point A is going to land here on the y-axis. We could do the same with B. We do have to redraw our little perpendicular line. But to draw it just means you're running from corner to corner to corner to corner. That's your line. And we can see that point B is 1, 2, 3 and a half little squares. But I've got a half square right here. So I'll go a half and then the next 3. I'll go 1, 2, 3. And that's point B plotted. And then C we would do the same way. We go 1, 2, 3. So we go to the other side. 1, 2, 3. And we land right there. And that point's coordinates are what? 6. 1, 2, 3, 4, 5, 6. Yeah, so that's 6, 0. And B is at 1, negative 6. And then point A, it was at negative 2, 0, so its image will be at 0, negative 2. And we knew all this because we already knew the rule. The rule for this reflection was xy turning into yx. But that's it for 9. And then 10 is these reflections over these horizontal lines that have been moved away from the x-axis. Normally, we just reflect over the x-axis itself. But we're going to reflect over this dotted line. And it's pretty easy. So just look at B. It's going to want to move straight up. And since it's 1 unit below, it can move 1 unit up. You can do the same with A. It's 2 units above. It really only wants to move straight down because of this mirror line. So it's going to go down by 2 and be right here. And that's it. That's how we reflect over that line. If you're wondering if there's a coordinate notation rule, like xy maps onto blah blah blah, well yeah, there is. But you don't need to know it. And honestly, I think I forget it, so I'm not telling. Yeah, not telling. You don't need to know it. Don't even worry about it. Let's do this one though. I see point C 1 unit to the right, so I know C prime will be 1 unit to the left. That's all. And I'm not counting from the origin, I'm not counting from the y-axis, I'm counting from the mirror line, remember? These distances I'm using are the distances from here, from the mirror line. So the mirror line to point D is 1, 2, 3, 4, 5 blocks. So I'd have to go 1, 2, 3, 4, 5 blocks. That puts D prime right on the edge. We can connect them with dots. And then looking at that, you should definitely see that that's the right reflection. Okay, and then the only thing left is kind of doing the same activity again, just to see if you still remember it. I think it's worth your time to do this more than once to make sure it really sits in your brain. So what happens when you change the sign of y? We said, if I'm positive and I change, I'm going to go up, yeah. It's definitely going to be that movement over the x-axis. So reflection over the x-axis, there it is. That's going to be the first one. All right, the next one, if we're adding a onto x, that's going to push us to the right. So you're looking for translation a units right, and there it is here. So that again is xy, mapping onto x plus a comma y. The next one, we see the coordinates flipping, so that reflection over this funky diagonal line, that's that guy's rule. So xy maps onto yx. Then this one, they're subtracting a from y. That's going to pull us down. So you're looking for the one that says translation a units down. Here it is at the bottom. xy maps onto x comma y minus a. Okay, I think that's... Oh, I've been bouncing around. Okay, so this one then, there's a negative, but we're not switching the order. It's still xy. So you could draw anything, draw a little triangle or whatever. If they start changing the sign of all the x's, then this point is going to bounce over here. This point bounces over here. This point would bounce over there. And that would be your new venue, I guess. But you know, you can do that reflection by just kind of plotting points, or you can do it by using the rule, coming up with your 3 new vertices and plotting them. That's probably the more careful way, but I feel good about it. So this is the one where we reflect over the y-axis, so this will be xy, mapping onto negative xy. And then lastly, we see that something's trying to pull us b units to the left, and it's also trying to push us a units up. So that's the very first one. It's x minus b and y plus a. That's it. That's the whole review. If you still feel iffy, don't forget there's a Delta Math available, so you can go over to Delta Math and do it. You don't have to, but you could if you wanted to. Could I even take you over there? Maybe I could. So if you're wondering about the Delta Math, then you're going to have to log in. Hold on. There you go. There's the internet. You're going to go to Canvas, of course. Log in. Go to geometry. The link is not on the home page yet. I'll put it there. I said I would, but it's in announcements. Hopefully announcements is another place where you guys will find stuff, because you should be getting notifications. But right here it says review for transformations quiz. This is the Delta Math one. Now you can't access it unless you signed up, and a lot of you guys didn't sign up. So this link you see is actually the link to sign up. I don't remember what happens if I click it, so I'm going to click it. I think I'm already logged in, so I'm going to say cancel at this point. But once you guys are in, you can log in. Now in my account, you're going to see a whole bunch of buttons pop up with a whole bunch of different things, but really what you're going to see is this sample student page. You're going to see one thing. There's one assignment here with a bunch of different options. So you could start at the beginning if you want to learn how to translate, reflect, rotate a whole figure, or if you just want to translate a point. I think you might want to just hop down to the point ones. Some of the ones up here, the first three are a little complicated. But here where you're translating a point, it just says what's the image of this point after translating 2 left and 1 down. So 2 left would take 1 and subtract 2 from it, so you'd be at -1. 1 unit down would take the y value, subtract 1 from it, so we'd go to 7. And once you've entered it, you say submit. It's going to ask you if you're sure. Then you should see that black question mark turn into a green check mark. And it tells you how to do it. And let's say you were lost. You click on this video.
Translation of a point.
And there's videos.
What is the image of the point -5, 2? After a translation, write 3 unit.
So you could watch those if you wanted. I've already got, you have to get 2 right. Once you get 2, you can move on to the next section. But you can move on to the next section anyway. You just hit back, and we could just leapfrog out of here and just go into the next one. So if you got stuck somehow because you kept getting them wrong, you just kind of quit out and start again in the module that you want to. So this time we're doing a reflection. So what would we get if we reflected over the y-axis? Well, the y-axis is the vertical one. When you reflect over it, this -6 that's on the left is going to become a +6 on the right. So you know your point is going to be 6, 5. Say submit, say yes. And it's showing you the math. It's showing you the rule, showing you the math, how to do it, giving you the answer. For rotation, it's going to be very much the same, of course. So hopefully you guys will take advantage of the delta math. Yeah, I don't know. Good luck. Good studying. I'm going to get this video out as soon as I can. It's already 8:25, so hopefully it'll get to you guys in time. See ya. Good night.